Looks like some of you have finished and you're just bored to tears. So feel free to turn your paper upside down, send it towards the middle here. I'll come get it in just a minute. Let's see how we did. All right, very nice. Good job. Whoops, look at that. Nice job. Thank you. All right, good job. All right, I'll come through with another pass in just a minute. So try to wrap things up, get that last letter. Maybe just guess if you can't figure it out. Excellent, thank you. Oh, you guys are done. Let's see how you did. Yeah, did okay? Good job. Oh, you're just meditating. Oh, it's that last one. You can't decide. Oh, you can take a guess. Oh, Will, you didn't want to. You wanted to make me walk. That's fine. It's good. Good to get my steps in. All right. Let's see. Curious. Oh, I know. Yeah. Do what you thought the first time. Yeah. Second guessing is usually bad. Yeah. Let's see. I'm curious. All right. All right. Good work. Good job. Okay. I think I got them all now. Any holdouts? Let me find my stapler. There it is. Okay, so let's see how you did. See how I did. And remember, this is doing several things for us. It's worth almost nothing, so you don't have to worry about doing poorly, but you're going to learn and hopefully do better when you get to your exam. In fact, I give you lots of opportunities to fail because that's how you learn, is you learn through making mistakes and learning from those mistakes. So if you get this back and you're like, oh, a 60, that's great because you won't get a 60 on the exam. The exam will be really similar to this. All right, let's see how we did. Convenience sample, that's that first one is a convenience sample. Then the second one, let's see, I got to read these over. That's cluster because you're grabbing tables, clusters of students. 30 students are chosen at random so that 15 are on one side, 15 are on the other. That's a stratified sample because you have a group from one side, a group from the other. Students entering the cafeteria has to put their names in a jar. That's random. 30 students chosen every 10th. That's systematic. You're choosing every 10th student, so very systematic. Conducted, calling randomly generated. That's definitely a random sample. Website, that's convenience. I got to remember what my letters are. So convenience is that one. Computer manufacturer every 36th. That's systematic. So anytime you're doing every certain number, systematic, think of it. It's very systematic of you. Charitable organization sends a survey to 50 people who were selected at random. I guess there's got to assume that they're doing a random sample there. And then 30 of their Apple stores and doing every employee. That one is a cluster sample. So I know you can't see all of this. There it is. Well, there. If you're watching the video, you can pause it now and look at the answers. So there you go. Hopefully you got most of them, if not all of them, correct. Okay, yes, sir. Yes, number 10. So we've got 30 Apple stores, and we're going to interview everyone at those stores. So we randomly select the stores, and we go to those stores. We say, okay, we'll take everyone here. Everyone here. It's like the clusters of grapes that you might get when you're at a dinner party, and they've cut off the little. That's what I think of when I think of cluster sampling. Is you grab a little cluster. I'll take all the grapes in that cluster, and then all the grapes in that. You get it on your plate. So it's similar also to the other cluster sample up here. You're choosing tables and you're grabbing all the students at those 5 tables. So it would be like if I'll take everyone in your row and maybe everyone in the back row, just so I don't have to walk too much. Just sample those people. Yeah, what do you think, Hayden? Okay, yeah. You could argue that in many of these situations that I'm doing a convenience sample if I was doing that in this classroom. I'm just doing my best. Honestly, it doesn't not worth that much here. But sometimes if the wording is not clear and you have a good argument for why it should be one way instead of the other, especially on an exam, I'm usually somewhat um, pliant when I hear your arguments and your cries for mercy. So if you do have a major problem with any of this, please do see me afterwards, and we can haggle it out, and maybe I'll accept two different answers. But for now, we do need to move on to the new material. And before we get started, I should say I have your survey finally. So you can either take it right now, or I'll send a link to it later. Now, if you want to take it now, you just have to scan this and go to it. Now, I would ask you, once again, you don't have to answer truthfully, so don't worry if you don't want to disclose anything, just make something up. But it would be more fun if we have truthful answers. Secondly, there are some, yes? Yeah, absolutely. Of course. Sorry, I should have prefaced that with that. Yes, it does say in the syllabus, no phone usage unless it's part of the class. But there is a part 2 to the survey. And once again, I'd ask that you guess, just do your best guess for those answers. You could certainly get the answers with a nice internet search, but do your best. And I'll give you a minute or two to, I should have put this up earlier so you could do it after your quiz, but I wasn't totally ready up here, so my apologies. So I will send a link to this in an email in a little bit maybe after chapel, just so that if you don't have your phone or if you don't want to bother with it right now, you can do it later. But this will just give us some data so that later on I can have you do fun things. Maybe it depends on what kind of data I get. So maybe I'll actually get that email ready now since I'm just up here bored. Oh, I should have mentioned that the reason why it'll collect your name is so that I can give you a quiz grade for this. Basically, you get 100% just for doing it. So, so if you felt bad that you got one of them wrong on the quiz today, this will balance that out, perhaps. All right. Well, it says that at least one of you has finished the survey. So, uh, um, oh, 3 now. That's fine. I'm not going to worry, but you can finish it up. Take your time. If you get bored, today you can use your phone during class, but don't watch the Final Four, whatever's going on. Is it the playoffs? Football playoffs? Is that what's happening this weekend? Kansas City Chiefs, go Chiefs. Is that okay? No Chiefs. Okay. Well, I don't know what to say. I don't really have a dog in this fight, but that's the only team I know is in the playoffs, so I have to say something. Okay, so anyway, as you're bored, you can finish filling this out and so on. But let's go ahead and move on. So today there's a few more um, uh, definitions, a few calculations we have to do, and then if we have time, I have a better, maybe a better example of how you might do your survey, or not your survey, your project. Project one is just to find a data set. So some of you have tried and maybe failed, and so I want to give you a little bit more of a hint as to how to do this, because I did it this morning in my office. It took me literally 1 minute, and I was shocked. Like, I tried to do it in front of you. I thought I would do it quickly, but so at least I know what to search for now. Okay, so we're going to be talking about experiments, some basic definitions first. And so experiments answer questions like, does aspirin reduce the risk of heart attacks? Is one brand of fertilizer more effective in growing roses than another? Is fatigue as dangerous to driver as influence of alcohol? Those sorts of questions we can answer using experiments. And so in order to understand experiments, though, we need to understand the difference between what we just did and an experiment. What we just did was not an experiment. What we just did with this survey is an observational study. So an observational study, the difference between an experiment and an observational study is that in observational study, I'm not trying to manipulate you in any way before or after the gathering of the data. So that's the main difference, is you're just observing and measuring some characteristics. This would be a survey. It would be something where I just look and I say, okay, what's going on in this population? That's it. You're not attempting to modify the subjects that are being studied. Now, that word modify might seem a little bit weird, so so let's explain what I mean by that. And that has to do with the word experiment. An experiment is where we do modify the subjects. And so here's one way to think of it, is that you're going to apply some controlled factor and then observe the effects of that on the subjects. And by controlled factor, I mean that I'm going to take something, I'm going to do something to this sample, like I've got a sample of students here. I'll do something where on one side of the room, I'll do something like maybe give you your exams in a smaller font than I normally do. And on the other side of the room, I don't do any, that's the control group. So that's a controlled factor, is that you're comparing what happens when I apply this thing to the sample and to when you don't. So this controlled factor, we just need to be able to be cognizant of the fact that that is the thing that you're changing, you're manipulating. You also have experimental units that this is from the homework. I want to make sure that you don't lose your mind when you're doing your homework. And so experimental units are just the things, the people, the objects that you're experimenting on. So I've got a string of examples here, and then we're going to move on to some calculations, which is it's not something about the experiments, but so this is the only real definitions that we have for today. So here's an example. I'll do this one for you, and then I've got several for you to do. So this first one, a Pew Research Center surveyed 2,252 adults and found that 59% of them go online wirelessly. Is this an observational study or is it an experiment? And if it is an experiment, there should be a controlled factor. So in fact, there is no controlled factor, and so this is an observational study. We're just surveying. Most surveys are observational studies. Just let's contrast this with the next one. I guess I'll do two of them, then you'll do the rest. The second one, that in the largest public health experiment ever conducted back in the 50s, I believe it was, the 200,000, a little bit more than 200,000 children were given the Salk polio vaccine, while another 201,000 or so children were given a placebo. So in this case, we have this sample of 400,000 children. The polio was a huge problem back then. And I remember my dad talked about some of his friends who had polio and were confined to wheelchairs or had other issues. So this was a big issue. So this is a major advance in public health when this came out. But back to the experiment, obviously it is an experiment, maybe not obviously, but anytime you have a sample that is broken into two groups, So we have these two groups. One of them is given the vaccine, one of them is the control group. That's why we call it a controlled factor. Anytime you have that sort of a situation, we have an experiment. The controlled factor is the vaccine. And by the way, this was so effective that they actually cut this experiment short because so many children in the control group were getting polio who needn't have gotten it. And so they're like, we got to stop this. We're just going to give the vaccine to everybody. And we have eradicated polio in this country because of this vaccine. Anyway, getting back to some examples, I've got several more for you to do. I guess I've got four or five. So here we'll just go through these. Go ahead and take your own guess. Is this an observational study or is it an experiment? And if it is an experiment, you should be able to identify the controlled factor. And I'll just pick some randos to answer. Oh, let me see. Am I recording? I know Dante is going to want to watch this. Yeah, we're recording. All right, so let's take a look at this. A pharmaceutical company wants to determine whether a drug benefits patients with restless leg syndrome. So what do you think, Alec? Is this an observational study or an experiment? Yeah, it would be an experiment. Now, this one is a little bit less, it's a little bit less informative than the previous one, is it? Because it doesn't give you all the details. But I think Alec has this sense that, yes, it's an experiment. Alec, since this is an experiment, what would you say the controlled factor would be? The drug, yeah. If you're gonna do this right, or if this particular pharmaceutical company is gonna do this right, they'll take some people who suffer from this disease. They'll say, okay, you guys, you're gonna get the drug. Well, they won't tell the people. They'll just assign people. These people get the drug. These people get a fake drug, a placebo, and we will see what the results are. So yeah, the drug, very nice. Yeah, so this is, drug. This will be similar to on your homework. They aren't always as clear about the thing, but it should be implied in the description. Let's try another one. So we have another one. You can read this over, and then I'll pick a random person. All right, Caleb, what do you think about this? It's a certain, let me read it over just so in case. A certain researcher wants to know what percentage of American adults can correctly identify the current president. Caleb, is this an observational study or an experiment? Yeah, it's an observational study because we're not gonna, if it was an experiment, and this is the key, this phrase here. If it's an experiment, there will be a controlled factor. And so if you think about it, what are you controlling? If you were to, I don't know, this is a typical question to give someone who gets hit on the head, like after gets a concussion or something. Do you know who the president is? To see if, I don't know, if their brain is working properly. So if you were to hit some of them on the head and then ask them and then don't hit others, then that would be an experiment. But I think there would be some ethical issues with that. So we'll just call this an observational study. Even if you were to do this with people who were just hit on the head playing soccer or whatever it is, it still would be an observational study because you weren't controlling who gets hit on the head. All right, next one. So take a look at this one. Research is done to determine if there is a connection between eating chocolate and increased mathematical ability. So take a minute and think through, is that an observational study or is there a controlled factor which makes it an experiment? Well, Sienna, what do you think about this one? It is, yeah. So what's the controlled factor? Yeah, it's the chocolate, or at least you could imagine it being done as an experiment. Of course, there's not enough information in this stem of this problem to really say it was an experiment, but we could imagine it being done as an experiment. Certainly, you could do this as an observational study, but it seems like it would be more effective to do an experiment and either give people chocolate before a math test, and maybe the control group gets what is the chocolate substitute, carob? You know, the fake chocolate. No one knows. Okay, yeah. I used to. My wife got my kids carob, like fake chocolate. Anyway, never mind. Okay. when they were little, because we didn't want them bouncing off the walls. At least that was the idea. So there it is. So let's try this one. Company wants to determine whether work contributes to depression. People were asked what contributes most to their sadness. So I'll give you a minute here to think about this. All right, Abby W., what do you think of this one? It's an observational study because there's nothing we're controlling. I suppose you might, yeah, I don't know how you would control something in this situation. Yeah, I guess, yeah, it's hard to imagine. Maybe the week before you load on a whole lot of, like, a bunch of work, put people under deadlines and stress them out, and then I don't know. But yeah, this is an observational study. Very nice. So just to clear things up, just to conclude, we're going to, experiments. We're trying to investigate the relationship between two variables usually, and those variables are the explanatory variable and the response variable. The explanatory variable, that's the controlled factor, just so you know. But eventually, we'll be using this language of two different variables. You have the thing that we're trying to use to predict something, like chocolate, and the thing we're trying to predict, maybe math test scores. So does chocolate predict how well you do on the math test? And so the researcher manipulates the explanatory variable, that's the controlled factor, and then measures the resulting changes in the response variable. Same thing goes for the drug study that we had listed, the restless leg syndrome drugs. You would have the experimenter maybe giving different groups different amounts of the drug and then asking them, how well did you sleep last night? And then, keeping the data. So you're trying to predict how well someone sleeps based on the number or the amount of drug that's in their system. So the experimental unit is just the person, the thing that you're experimenting on. All right, just as a quick review, since we've got all this terminology now, let's go back to the language that we had last time. Oh, I should have had that on my quiz. I just realized population, sample, and that sort of thing. Yeah, I should. Well, maybe next time I'll have it, because it definitely will be on your exam. So I definitely need to have one of these. But let's see if we can figure out all of this stuff. So this, by the way, is an experiment. So, so you have a population, a sample. We're going to have experimental units, explanatory variable, a response variable. Don't worry about the treatment. I should have also had statistic and parameter. Well, we'll do that another time. So this is plenty here. Population, sample, experimental unit, explanatory variable, and response variable. So take a minute and see if you can identify those for this situation. I won't read it to you because you can all read. All right, well, let's slowly go through this. Don't worry, don't panic. It'll be okay. Elizabeth, what would you say the population is that we're interested in? Nice, nice. It's perfect. So let me write this down because this is an interesting situation that's true of heart research, at least for in the past. So in the 80s, 90s, the early 2000s, oftentimes the population under study was men. Men, women didn't get studied. And the reason why was that men generally had heart attacks in higher numbers than men, but heart research was generally done on men. So men, men between 50 and 84. So men, yeah. So all men. By the way, despite the fact that the research subjects were men, sometimes the people doing these studies would claim that their research applied to women as well. And maybe it did, maybe it didn't, but to exclude them from the sample means that they are really not part of the population. So sometimes this illustrates a defect of some studies. Sometimes someone will try to study a population, but because their sample is a subset, like these people might have been interested in all people, male and female, but their sample was drawn only from this population. So really, this study is only about men. But anyway, good. Thank you. What about Karen? Karen, do you know what the sample is? Yeah, it's specifically those 400 men. Very nice. So the 400 men that were studied here, I'll just underline. Where did it go? I was just looking at it. Oh, 400. There it is. So it's those 400 men that were actually in the study. Very nice. All right, now let's see if we can. Biella, what about the experimental unit? If you went down to the individuals, who are the individuals in this study? Yeah, the individual, the men, the dudes. So the men. So the men or experimental units, they're each man is one person, one thing. Very good. Explanatory variable. What is it that we're trying to use to predict? So Hayden, what do you think we're using to predict something? What is our explanatory variable? Very good. So do you take aspirin or not? So that's the explanatory. We're trying to explain heart attacks based on whether or not you take aspirin daily. Okay, response variable, that pretty much gave that one away, but let's get it anyway. Pete, what do you think the response variable is? Yeah, heart attacks, heart attack. By the way, we can even drill down deeper on this one. The aspirin is qualitative, right? It's yes or no. Did you take, did you not? Heart attack, yes or no as well. So in this case, we have an explanatory variable that is qualitative and a response that's qualitative. You can imagine mixing things up so that your explanatory variable is qualitative and the response is quantitative. This would be if I gave two different colored versions of the exam, red and blue, and that would be my explanatory variable. The response would be your grades, quantitative. So there's different ways to set up experiments and to make comparisons. We'll be looking at most of them throughout this course. But let's go on. We do need to move on to the next topic. And then if we have time, we'll talk about the project again. So the next topic is frequency distributions. By the way, it feels like I'm rushing a little bit, but this is all easy stuff. And I should mention that on Monday, you might have noticed this already, but if you look at the homework on Monday, I actually say in the homework page, you've got 2 sections to do for Monday on Newton. So just be aware of that. There's a section on experiment versus observation, super easy. And then there's a section on frequency distributions, a little homework set, a little bit harder, but not terrible, not terrible. This one actually involves calculations. I should have mentioned earlier that I'd like you to have your own calculator. I have a few here, so I'll bring a few out to show you. Oh, I have my secret stash up here. Yeah, there we go. There's a few more. But I just want to show you what I would recommend. So find a friend who has a calculator, because here we're going to use calculators. So these calculators, here I'll show so that if you're watching the video, you can see. Give me a sec here. Where's my camera? Camera it out. There we go. So this calculator, it's terrible. I mean, you could use it, but it's a piece of junk. Same thing with this one. So both of those, I mean, they will work. They're okay, but they're not great. So I wouldn't, well, you know what? You probably could get by with these. Yeah, they're okay. They're okay. I just hate them. So I have them over there for you to use if you come in and you don't have a calculator in an exam. This one's better. It's called the scientific calculator. That's that's all you need. You don't need to get some fancy calculator. This will do everything. The reason why I like this more than this is that this one will follow the order of operations, which will trip some students up. You'll get the wrong answer mainly because your calculator is terrible. So this one does not follow the order of operations. So scientific calculator does, that one doesn't. This type of calculator is overkill for this class, but if you want to feel good about yourself? I don't know. Maybe you have one from high school. Yeah, you got one. Very nice. I actually worked with one of my former colleagues. She's retired now. Did an experiment um, into whether or not the presence of a calculator helped students do better on exams. And what she did was she had three groups. One group had no calculator. One group had a calculator that looked like this. The third group had a photograph of a calculator that looked like this on their desk. Turned out that the calculator increased test scores, but so did the photograph of the calculator. Amazing. I love that. But anyway, this is also overkill. This one's in color. This is actually one of my daughters went to college, and I got her this, and then she said she didn't need it anymore, so she gave it back to me. And I was thrilled because it's the best calculator I have. Okay, so that's the calculator situation. You'll want to use a whoa, that's not what we're doing in here. Where are we? Back to PowerPoint. So I mentioned that because on the exam, you can't use your phone. So maybe you're saying, well, that's the only calculator I own. Well, find a friend. You don't have to buy one. I don't encourage you to go. I don't want you to buy a calculator, but find a friend who has one that you can borrow for this class. You can borrow one of mine. I only have a few over there though. So if you need a calculator on an exam, and I know some things, some days you turn on your calculator and the batteries are dead. So I've got several over there that you can borrow on exam. So I mention that because we're doing some calculating. Here's some calculating here. So frequency distributions are just a way of keeping track of quantitative data. Really simple. This you've probably done before. This is the Rotini thing that I told you about last time, that my kids came home from elementary school with construction paper with like pasta glued on it, and each of the pasta represented another child and their favorite color and whatever. So anyway, this is just fake data because I don't have the real data from you, but I will on Monday, hopefully. So basically, to make a frequency distribution, you're just counting the number of individuals that fit into each category, and the categories might be a range of values, or they might be a single value. In this case, it's a range of values, and so we have here 2 people. I'll just cross them off when I get to them that fit into that category. Into this category, 1, 2, 3, 4, 5, 6, 7, 8. 8 people. One thing to note is that my categories are all the same size. This is important, that if you're going to divide people into categories, they should be the same size, in the sense that this spans 15 units of whatever this means, these fake numbers. Notice it's 10, 11, 12, 13, 14, 15, 16, 24. That's 15 numbers in that range. Same thing here. Another way to look at this is that the difference between 10 and 25 is 15, and that is consistent all the way down. 25 plus 15 is 40, plus 15 plus 15 each time. So that way they're same, you've got the same size of the bins or the groupings. The next one. So I know this is babyish, but bear with me. I'll get something more interesting in a minute. That's 3. 3 in that category. Let me know if I make a mistake though, because I'm prone to mistakes. 1, 2, 3, 4, 5. Now I did get and that's 1. I did get a PhD in combinatorics, which is just a fancy word for counting. So hopefully I can employ those skills that I learned during those 5.5 years at Temple University. But there it is. So now that I have that, the reason why I went through that should be the easy part for you. The harder part is getting these next 2 columns. And this, as we go across here, more and more students get this wrong on the quiz. Yes, Oz. 55 to 80 is 25. Oh, what a ripoff. I made a mistake. Okay, let me see. So let's fix this. Thank you, Oz. How did I do that? So this should be to 69, shouldn't it? Interesting. Ooh, so that means this is 70. This is actually more interesting. Thank you. Okay, 55 to 69. Look at this. This is great. And then 70 to 84. And then I need here, just a minute. Just a sec. I'll just do this. Okay, so that's gone 70 to 84, and then 85 to 99. Does that work better? Wait, is this better? That makes you happy, Oz? Okay, well, if it makes her happy, hopefully it'll make everyone else happy. Thank you. No, thank you, seriously, because this is far more interesting. Let's see if I can count now. So I didn't say that I was good at addition, I just said I was good at counting. Okay, so 58, 58, 62, that's three of those in that category. There are two in this category, and then one in this category. See how good I am? Okay, so now I've got it good. Okay, so no one has ever called me on this before. Thank you. And I used this for the past 4 or 5 years, probably, when I made up the fake data. I guess they're just amazed that I got a PhD in counting of all things. But anyway, getting back to relative frequency, here's where usually, and this is where the problems occur, to get the relative frequency, we need to know how many data there are. So let's count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now I could have just added up my numbers, but if you count up the data, you can be sure there are 19 data. So I'm going to write this as n is equal to 19. So relative frequency is just the percentage, the proportion that are in each of the categories. So in this case, you have 2 out of 19, and I am happy. I'm happy for you to use a fraction here. But you could also write this as, 0.105 or 10.5%. So however you want to do this is fine. And there's 3 different ways. Okay, I'm going to write these as fractions, though, just to simplify and make this quicker. This is 8 over 19, 3 over 19, 3 over 19, 2 over 19, and 1 over 19. Okay, so that wasn't too bad. We can come up with our relative frequencies. You just have to know how many, divide, done. I can't remember if Knewton likes fractions or not. It seems like in some of the problems it likes fractions, some of them it prefers decimals. Just follow the instructions. If it says to round to a certain number of digits, you can do that. Now, this is the one that causes the most grief, even though, I don't know, maybe it's that word cumulative. Do you know what cumulative means? You're accumulating, right? Yeah, that's what you wanted to say. You're going to group it all together. So if I were to do a cumulative thing, I would ask like Carson, how much does he, maybe weigh? We'll do the weigh Carson, right? Okay, yeah. So if we want a cumulative weight, I would ask Carson how much he weighs, and then I would ask Joshua, and I'd be like, okay, these two people together weigh this much, and then I would ask Biela, and then I'd add all 3 of them together, and then go on. So that's cumulative. Cumulative means you're accumulating. So we'll do the same thing here. When we get to this number, that's all we have accumulated. So cumulative just means everything here and above. So here, this is all you have is 2 people. When you get down to this number, we have 8 plus 2. There are 10 people that are from, well, this and below. So basically, you're just adding the numbers together. So either you could look at it as you're adding these numbers together, putting it over 19, or you could think of adding these together. The next one, you're going to add all 3 of these together. So 3 plus 8 plus 2 is 13, 13 over 19. Excuse me. Anyway, you can do the rest of these. Go ahead. See if you can get these last 3. I'll bet you can. I'll give you literally 30 seconds because we do need to move on. All right, let's see how you did. This one is 16 19ths. This one is going to be 18 19ths. And this one is 19 19ths. By the way, if you've done this correctly, when you get to the last one, it'll always be 100%. So if you think of it, how many people are at the very bottom category and above? Well, it's everybody because that's the last category. So everybody is up here, unless there's some rounding issues, but you know, this is fine. Okay, so here's the sort of thing that you're going to have to do on your homework is you're given some fake data like this, and you're supposed to come up with the missing number. And as long as these are the only categories, you should easily be able to do this. See if you can do it, and then we'll pick a random person to tell me how you did it, because I have confidence that you can think through this. All right, Kaylin, what did you do? Or do you have an answer? All right, do you have any ideas? You could just tell me what to do. So the key here is that these should all add up to 100%, shouldn't they? Because this is everyone. Okay, I'll add them together. I did it here. I added these together and I got 0.81. Well, okay, that's terrible, but 0.81. So now what do I do? So 0.19, because we want the total to be 100%. Very nice. So 19% there to make the total. So if the rest of them are 81% or 0.81, then the missing one should be 0.19. Good job. All right, a little bit more fake data. Here's an example where I've got these this data divided into these groupings, and I tell you up front that there are 30 data values. You have to come up with the missing one. Okay, great. Okay, let's see how you did. Oh, find my volunteer. Sorry, I was checking on my thing here. All right, Abby L. What would the missing number be here? It's 1. Now, how did you get 1? Very nice. So if you add all these together, you do get 29. Well done. And then if there's going to be 30, there's only 1 missing there. Good job. Okay, I do have, my next thing was statistics you can use, but we're going to have to save that, I think, for next time because I don't want to rush that. So we'll do that on Monday. So let's just talk briefly about the projects. The first project in particular. Here's what I did this morning. I'll just show you really quick so that you can be encouraged that this isn't as bad as you might think. I did a DuckDuckGo search because that's our favorite search engine, right? For football results Excel data. And I thought, oh, this is going to be great. I'll get some football like the Kansas City Chiefs and beyond. But everything was European or like real football, not American football. And so I thought, well, who cares? You know, we can do this. So I clicked on the very first one, and you'll find that this very first one, wait, where is, come on, click. There it is. So I went here and I was like, oh man, I have to pay money to get these data down here. But they have some freebies. I was like, hey, you know what? Let's check out players.csv. So I did that. And the players, when I pulled that up, I thought that looks pretty good. Let me pull it over. It's going to show up on my other screen here. Just a sec. So here's players. Check this out. Whoops. Make it big. So these are players in the Premier League in 2020 or 2019, and they have the name, birthday, the league that they're in, the position. They have so many numbers. This is a great data set because it has, let's see, nationality. You have qualitative, nationality, position, current club. Those are all qualitative, and you have quantitative, the minutes that they've played. Their birthday is sort of a quantitative, I guess, age. So many quantitative variables here. So that one's beautiful. So I'm not going to add this to the list, but if you're dying to find something and you're like, I don't know what to put up there, you could, if you can be the first one, what I would do is I would put this up here as the title is Premier League 2018, 2019 players. So I'd put that in the title, and then I would use this up here as the web address when you fill out that survey to tell me what your which data set that you found. Anyway, if you are having trouble finding a data set, here's some ideas for you. Just a sec, one more thing, and then we'll be all done for the day. And we're not going to do this right now, but you could think of what are your interests? Like, is there a sport that you enjoy watching or participating in? Maybe you're into football, European football, or what the rest of the world calls football. Then that would be perfect for you. So what about one thing you enjoy doing for fun that's different from your answer to A? So things that you're interested in, find data sets that you're interested in. Maybe you're interested in darts. You can look for the International Darts Championships and various information about the players, what their scores were, whatever. Something you would be interested in learning more about. Perhaps you're just interested in astronomical events and you want to know, like, what are different stars? I don't know, something from a class you're taking this semester. And then finally, you could look into your major. The major, by the way, I found is not as good as one might think for finding data sets. Now, that's not to say that your majors aren't scientific. It's just that usually they're too scientific. And so to find a good data set that's related to nursing, you end up getting something that is way more complicated than you want it to be. Or like, I know the social work people, they're always like focused on suicide. They love suicide for some reason. And so the social work majors are always getting suicide databases, but they're way more complicated. I mean, you can work with a suicide database if you want. Like this is they'll get a database with information about different suicides in Ohio or whatever. But it usually is a little bit harder to work with. If you're still stuck after you're done with this, if you're thinking about these items, come see me with this list. So next week, next Tuesday, next Thursday, great times because I have almost nothing on my schedule those 2 days. Good times for you to make an appointment. Come see me, and I will sit down next to you, and I will help you find something that is going to interest you. And you can put it on the list for your data sets. You have to do this twice, by the way, and the reason is oftentimes the first one that you pick is garbage, and you won't know that, but I will. It's not that it's garbage, it's just that I might look at it and say, you're going to have a lot of trouble later on with that data set, and I don't want you to suffer. So I want you to have a good data set. So that's why I'm having you pick two, and I will let you know if either of them is bad so that you can pick the other one. Okay, that's it. If you want to stick around and chat, you can.